Number 11, a curve has slope 3x squared plus 4 at each point xy on the curve. Find an equation for the curve as it passes through the point 2, 10. All right, it does not say find an equation of the tangent line. It says actually find an equation for the curve. So we want an equation. We want like a y equals. This one says that it has slope 3x squared plus 4, which means the derivative of my curve is 3x squared plus 4. So if I just want the curve, if I want to go from the derivative of the curve to the curve, I know that I need to take the integral. So I'm actually going to be taking the integral of 3x squared plus 4. So my curve will be y equals, since there's a plus sign, I can just take the integral of each part separately. The integral of 3x squared will just be x cubed, and then the integral of 4 will be 4x, and of course we always have to put our plus c. And since we would like it to pass through the point 2, 10, that will help me find my c. So 2 is x and 10 is y, so I'll get 10 equals 2 cubed plus 4 times 2 plus c. That gives me 10 equals 8 plus 8 plus c. That gives me 10 equals 16 plus c. So c would have to equal negative 6. So an equation for my curve will be y equals x cubed plus 4x minus 6. Right, number 12. The base of a solid S is the region enclosed by the graphs of y equals x cubed, x equals 4, and the x-axis. If the cross-sections of S perpendicular to the x-axis are squares, then find the volume of S. All right, I know I'll be doing cross-sections, so I know the formula for the volume is just the integral of the area in question. Right, I'm going to go ahead and draw a picture. X cubed looks like this, and x equals 4. Not quite as steep, it's going to look like that. So I know that this is the area in question. The cross sections will be perpendicular to the x-axis, so they'll be going up and down, and they're going to be squares. So the area of a square, I always like to do a little side trip, the area of a square will be side squared, and to get the length of the side, it's going to be the top minus the bottom, since I'm dealing with the x-axis. So the top of the curve will be x cubed, the bottom of the curve will be 0, and that gives me x to the 6th. So the area is equal to x to the 6th. All right, so my volume is equal to x to the 6th dx, and then since it's in terms of x-axis, we're going to go from an x value to an x value, which will be some 0 to 4. All right, the integral of x to the 6th will be 1/7 x to the 7th. I get to evaluate it at 4 and 0. And when I plug in 4, I'll get 4 to the 7 over 7. And then if I plug in 0, I'll get 0. So my answer would be 4 to the 7 over 7. If you'd like to evaluate that, you go right ahead. All right, number 13. The first derivative of the function f is defined by f prime of x equals cosine of x squared minus 2 for x being between 0 and 3. On what interval is f decreasing? Well, if I want to know where f is decreasing, I need an f prime chart. And fortunately, I'm given f prime, and I do get to use my calculator, so I'm going to actually look at what f prime looks like. So I'm going to graph f prime, and if I do, it looks something like that. And actually, I think it comes down a little bit. Alrighty, so what we're going to do is figure out where do these equal 0. We can use the 0 feature of our calculator to do that, and when we do that, the first one's going to be 0.655, the second one will be 1.890, and the third one will be 2.591. And then if I look at this graph, the graph is below the x-axis till I get to 0.655, so it will be negative. It's above the x-axis in the next interval, so that will be positive. It's below the x-axis in the next interval, so f prime will be negative. And then it's above the x-axis after that interval, so the f prime will be positive. So when I'm asking for where is f decreasing, there are two spots where the graph is decreasing. They are decreasing on, where did this graph start at? 0, 0 to 0.655, and then again from 1.890 to 2.591, and that would be because f prime is negative. Problem 14. The derivative of the function f is given by f prime is equal to x squared minus 2x sine x, and it says how many points of inflection does the graph of f have on the interval -3 to 3. So if I want points of inflection, I need an f double prime chart. So I need to find f double prime. So if I have f prime, I'm just going to go ahead and take the derivative. I'll take the derivative down here. The derivative of x squared would be 2x, and then the derivative of this part I'm actually going to use the product rule for. Get f prime is equal to 2, g prime is equal to cosine x, so this will be minus f prime times g, so 2 sine x, plus f times g prime, 2x cosine x. Alrighty, I'm just going to distribute. I'll get 2x minus 2 sine x minus 2x cosine x. That's my second derivative. And then just like I did in problem 13, to actually find those values, we can actually draw f double prime. And if we do this, f double prime will look like, let's see, boom, 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 boom. This graph hits right at 0, 0. And then it hits about right there. And then it hits about right there. Looks like it goes up and then down and then back up. So it looks something like that, I feel. This is a picture of f double prime. So if I'm doing an f double prime chart, I notice there are zeros in 3 places, and I can use the zero feature of my calculator to find those. This first one will be at negative 1.307. The second one is at 0. And the third one was at positive 1.307. Okay, that graph is below the x-axis, and then it goes above, and then below, and then above. So when it asks me for how many points of inflection does it have in the interval negative 3 to 3, we see that there are 1, 2, 3 places, and that's because the second derivative changes sign 3 times. So 3 points of inflection. What are those coordinates? Well, we already found them from doing my chart. Negative 1.307, 0, and 1.307. Right, problem 15. A particle moves along a straight line with velocity given by v of t is equal to the cube root of t e to the t squared plus 5 for time t is greater than or equal to 0. What is the acceleration of the particle at time t equals 4? Okay, if I'm at velocity and I want to go to acceleration, I'm taking the derivative. So acceleration at 4 will equal to be the derivative of the velocity at 4. All right, there's probably a couple different ways you could do this. If you really want to work this out the long way, go for it. But since we get to use our calculator, we can actually use Math 8 to help us do that. We'll be evaluating the derivative at 4. So the easy way around it would definitely be to do that. And when you do that, you're going to get 695.904.